Okay, spend a little more time on those coincidences, or are they coincidence that the sine of 60 and the cosine of 30 have the same value? Now, as you may have guessed, those are not coincidences at all. In fact, there's a very good reason why they're the same. So let's take a look at let's say the sine of 30, for example. If you take a look at sine of 30, it represents, here's 30. If you go across from 30, it's 3 divided by 6. Opposite over hypotenuse. 3 6 equals 1/2, right? Now, if you go to the 60-degree angle and you look at the cosine of 60-degree angle, it's using the same two sides. The cosine represents the adjacent side, the 3, divided by the hypotenuse, the 6, the same two numbers. So it depends on the angle you're looking at. The sine of 30, you're going across hypotenuse. The sine of 60, you're going next to over hypotenuse. That's why they're the same values. We have a name for those, and those are called complementary functions. Just like complementary angles add up to 90, complementary functions, the angles add up to 90, and the ratios, your answers, are the same. So I just want to make this clear by doing a couple of examples. Anytime you see the word CO in front of a function, so for example, cosine, cotangent, cosecant, that CO stands for complementary. So let's see how it works. Let me just get a new page here. We'll add a blank page to the document. And what I want to do is I just want to give you a couple examples how this works. So we've already done the sine of 30 degrees. The sine of 30 degrees equals the cosine. Well, ask yourself this question. The 30 degrees, what's the complement of 30? Well, to get to 90, I need 60 degrees, so this would be the complement of 60 degrees. And then we've already determined that that would equal 1/2, so they both equal 1/2. So the sine of 30 has the same answer as the cosine of 60. Let's take another cofunction. The tangent of 10 degrees, for example. If you were to take the tangent of 10 degrees, that would equal the cotangent, the complementary function, cotangent. Ask yourself, well, what's the angle that you need to get up to 90 degrees? That answer would be, well, 90 minus 10 is 80. This would have to be 80 degrees. This would be a true statement. Okay, a couple more. How about the secant? The secant of 40 degrees, for example, would have to equal its complementary secant. Cosecant would be, it's abbreviated CSC, cosecant, and that would be 50 degrees. And so those would be examples of relationship. And of course you can work the other way too. You can be given a cofunction. For example, if you were given the cosine of, I don't know, let's say 75 degrees, and that would be the same answer as the sine, right, because that's a complement. The sine would be the complement, and the sine would be, to get up to 90, you would need 15 degrees. So these are true statements. They're equal statements. They're also known as a cofunction identities, but the important thing is that you know they're complementary. Now, 30 degrees, 60 degrees, we've got the exact value there. These we'll hold off on getting the exact value. We'll do that later on. But maybe just one more. Maybe we can do the cosecant. If I threw one in here, cosecant of, I don't know, how about 45 degrees? The cosecant of 45 degrees would equal, let's see, the cosecant would match up with the secant, right? The secant, so SEC for secant. Well, what would be the complement of that? And that would be 45 degrees. So both the cosecant of 45 degrees and the secant of 45 degrees have the same answer, which would also be true for the other one. So the sine of 45 degrees also equals a cosine of 45 degrees. That would be the same answer as well. All right, now don't be confused between cofunctions, where you have complementary going on, and what we first started trigonometry with, which was reciprocal ratios. So don't get these confused. The cosecant is the reciprocal of the sine. The secant is the reciprocal of the cosine. The cotangent is the reciprocal of the tangent. However, the sine and cosine are complementary. complementary. That's where the CO comes from. I know it gets a little confusing, but you got to try to keep those straight. Reciprocal ratios versus cofunctions. Okay, after you work with them a little bit, I think it'll become clear. All right, so that's cofunctions. Before I do inverses, this might be a good place to stop, but I do want to show you before we move on to the next video. Let's just do it on the graphing calculator to confirm this. So again, make sure press the mode button. Make sure you're in degree mode because I'm going to be working in degrees. And second quit to get back to the main menu. And let's just test some. So for example, if you wanted to do the sine and cosine, because they're complementary, you could just type in the sine of 60 degrees, for example, and get an answer, which is it's an irrational number. It's about 0.87, let's say. We know the exact answer is, we have it on our screen over here. If I just slide this over, you can see that the exact answer is square root of 3 over 2. And if I were to do this cosine, the cosine of 30 degrees, it should have the same answer because those are complementary functions. So if I press enter here, I'll see that sure enough it has the same answer. So that kind of proves it. What I want you to notice about your calculator, however, is that there is no cotangent button. There is no secant or cosecant buttons. You're going to have to wait for trigonometry to figure out how to do those in your graphing calculator. It's not very difficult. The cosecant is the reciprocal of the sine. So really all you have to do is, if someone gives you the cosecant, you turn it upside down and then you use the sine button on your calculator. That's really what it comes down to. So it's not that complicated. It's just we don't have time to cover that in this course. So, but the cotangent, cosecant, secant buttons are not on the calculator because you can always take the reciprocal and use what's called the principal functions, the sine, the cosine, and the tangent, which are on your calculator. And that's really the three that you need there. Okay, I'm going to pause the video here. Next video will be on working backwards. What if you know the ratio and you have to figure out the angle?